Hi, I'm Kurt and welcome again to Comp Sci 5. Just to talk a little bit about what we did last time, we introduced the course. It's a course on solving problems and learning computer science concepts that you can apply to any platform just by Googling syntax, okay? That's the true benefit of this course. So we talked a little bit about three main concepts: data structures, algorithms, and computation. A data structure is just a container to hold some type of information, some type of thing, some type of data. It's a way to represent that in the machine. You don't just want to hold something in a machine to save. It'd be cool if you could do something to it. And to do something to it, you need a set of instructions in order to do that. And we call that an algorithm in computer science. And the focus of this class is going to be relating data structures to algorithms and using both these things to solve problems, aka computation. And to dive into it, we're going to focus on data structures first, because if you can't represent something in the machine in the first place, why would you ever learn an algorithm to do anything to it? I don't know. So let's go into what does a data structure look like physically. And a data structure can be thought of as this here box. It's just a container. That's all it is, just a container to hold some information. And like we know, boxes, these data structures, they can hold anything. They can hold numbers, they can hold letters, they can hold symbols, or they could even hold pictures, right? It's really only limited to your imagination. So what does this look like in the comp sci world? Well, it is this really cool thing called a node. It's called a node. And what all a node is this box in the computer. So to illustrate that, let's draw a little box here. And similar to all these things that I put in this here physical box, in this virtual box that is inside the computer, we can put just about anything. For example, we could put a smiley face with just a few string of symbols there. And wow, what a cute node. Or, oh my, guys, I'm sorry. Sometimes I just can't help myself when I get around nodes just because they're so cool. It's cool because you can put just about anything you want in the nodes. So, what if you were to put a node inside of a node, right? What would that look like? Well, it would look like putting a box inside of another box. Simple enough. So we would have a box. Let's say we put another node in the box. Let's say we put another node in the box. Now we have a node inside a node inside a node, but that's nodeception. That's getting a little bit confusing to wrap your minds around, right? So what we did as computer scientists is instead we store a data item and we also store a pointer or a reference to the other node, which can be thought of as this. So now, quite literally, these here nodes are connected inside the machine, right? They are connected. And what this would kind of look like as a picture would be so in every node we have a data and an arrow. We have data and an arrow, data and another arrow, so on and so forth, up into however many data items that you have. And what's going on here is we are quite literally linking up these two nodes. Link up, my brothers, link up. So here we go. We have this node that's linked to this node because we have data and a reference to the next node. And we also have it linked to that one. Notice how they are kind of chaining up, linking up Basically, all the nodes on the block are getting together and they're throwing a node party, and you're invited. But we don't just have this chain structure, we have a linked list, our very, very first data structure. And it is of linear, and you can put in any type of data. And just how cool is that? And that's really all the time that we have here today. Thank you for streaming in. Next time on Comp Sci 5, we will discuss what is an array. I'll leave you with that. Thank you.